In this lecture, I will explain about Advanced Encryption Standard or AES. As you know, I discussed this part of our lecture during our semester, but there was a problem with audio recorder, and I try to re-explain all this context of this lecture. As you maybe know, AES or Advanced Encryption Standard is a kind of symmetric key encryption which encrypts any plain text with some parts of blocks. This standard, like many other standards, was published by NIST, National Institute of Standards and Technology, in 2001. In fact, I don't explain the history of AES, just for remembering, we can implement this standard using different size of blocks. The block size can be considered as 128 bits or 192 or even 256 bits. And also the size of blocks and keys can be varied, with the same numbers. In fact, when you have a plain text, your plain text will be converted into a matrix of 4 multiply 4 of the size of 4 multiplied by 4, which we called it as a state. In fact, the state is the same as our input and this encryption standard. And in fact, we split our plain text into so-called word, as I will explain in the next slides. Sorry. AES also can be implemented using different number of rounds. The number of rounds can be considered to be equal to 10, 12 or 14. And till now there is no weaknesses over this standard. Here you can see the main construction of AES. As you can see in this slide, your plain text is equal to 128 bits, which is stored in an array, this one, which is called the state. This state is a kind of matrix. As I mentioned, this matrix is a size of 4 multiplied by 4. You can see clearly in this slide that in each step we have a state. You can see the output of each state of each step, is another state till the last part. Similarly, we have the same thing for our key. The key is organized as a matrix, as a state, and in each state we have a round key for each round, which is obtained from a master key. Hence we have several key such a state. Okay, you can see that this state is repeated in each phase in this standard. After initial transformation step, here we will have the first round of our algorithm. In each phase or in each round, we implement 4 kind of transformation, and these rounds are repeated until the last one here. Again, 4 kind of transformations are implemented over each state, which is the output of the previous round. And finally, in the last round, in fact, we have only 3 transformations over the state, and the final result finally is organized again as 100 to 28-bit ciphertext. Here you can see the main structure, in fact, in a short diagram. As you can see, based on the number of rounds, we can see the different key size is considered. Okay, and based on this key, we will obtain different subkeys for each round. Round number 1 till number R, and finally we will get our ciphertext. Note that before the first round, as you can see here, an initial round or pre-round transformation will be implemented over the plaintext. Here in this slide, you can see the data structure of AES standard. Here you can see our plaintext. As I explained, our plaintext is organized into a matrix. This matrix involves 4 columns. which are called as words. Okay, and finally our ciphertext is similar to our plain text, which means it is organized also as a matrix consisting of 4 words. And if we consider that the number of rounds is equal to 10, we will have something about 34 in fact keys, because in each round we will have 4 words and the number of rounds is equal to 10. And we have also one initial step before these 10 rounds, which yields to 44 subkeys or 44 words starting from W0, W1 till W43. As you can see here, all of these subkeys are implemented over these words which are obtained from our plain text. And here we can see we can compare different AES parameters. As you can see here, if the number of rounds is considered to be equal to 10, the key size is equal to 128 bits or 4 words, same thing. And our plain text block size will be the same, 128 bits. Okay, and similarly the keys that are obtained from our master key, they have the same length as the initial key here. Okay, and also if we wish to expand the key size, we can expand it. And similarly for the other number of rounds, we can see the key size, plain text, and also size of each round key. Okay, let's look at the different steps of AES.